Today we're going to save 100 euros, or maybe 1,000 or 3,000, who knows? Because today we're going to turn almost anything into a Wi-Fi alarm with an alert to your phone. And we're going to illustrate it by building ourselves a dock power current detector and thus save our batteries from a terrible death by depletion. But let's see how we could use the same technique to receive a notification on our phone when our boat's engine starts, or when someone rings the doorbell at our house, or anything else we can think of. Let's go with episode 28. Well, it really should be episode 1 of the second season. No, 28, because bigger numbers are simply better. 28. We're going to keep numbering it this way until the very end of time. It's going to be just like Santa Barbara, episode 1345 exactly. Well then, come on now, let's go right ahead and roll the intro in. Greetings sailors, and welcome to a brand new episode of the Low Cost Sailor. Throughout quite a few of our episodes, we've really emphasized that you should have a Wi-Fi network with a working internet connection on your boat, because I'm assuming you already have that set up at home. And thanks to that network, we've been able to make a ton of different connections between our Raspberry, our phone, and a whole bunch of sensors that we've been purchasing on AliExpress and then adapting to our needs throughout the 27 episodes we've produced so far. Basically, they're sensors originally designed for home use that, once adapted for a boat, can provide us with a lot of information and peace of mind, without having to spend the huge sums on dedicated marine monitoring systems, since those already exist. Today we're going to show you how to add a Wi-Fi alarm to pretty much anything you already have and can think of, so you can have alerts sent directly to your phone whenever, for example, our boat's engine turns on and off, and in that way keep a record of its use. Or if the low oil pressure indicator light comes on in case we leave the boat to someone we don't really trust, or if we have a charter company, or if the bilge pump switches on, or the engine overheats, or even when our home doorbell rings so we get a notification if we're not there. All of that is done in exactly the same way, with a very simple system that we already took a look at in our episode 24, when we turned a regular gas detector into a Wi-Fi gas detector. All of this comes from one of the devices I have installed. This current detector on this dock right here. I just unplugged it and it starts triggering a device that basically checks whether there's power in an outlet, and that was designed to check when the breakers trip at home or the power goes out, and it sends us an alert to our phone so we find out and take the appropriate measures. The one I have on my boat, this is a device that my company manufactures for one of our partners, and they sell it for home and industrial use with its own communication system and suitable to operate in any situation. In fact, this one doesn't need Wi-Fi. There's no doubt it works great, and not just because it was designed at my company, but because it works very well and is very easy to use. However, I myself don't consider it low cost enough for this channel. We're already getting to levels of low cost. The low cost of the low cost. This is low cost, but what we're going to do is low cost. The CPI has gone up by 6%. We need to save more. And at first, what I set out to do was look for an even cheaper alternative for you on AliExpress. A device that would work with Tuya Smart and that would notify you when the power goes out and when it comes back. And I'm pretty good at digging around on AliExpress. Well, I didn't find it. In fact, the only alternative I found to my company's device was recently provided to me by a follower of the channel from Dokenzip. They sent me a professional boat monitoring kit, this huge beast of a device, one of those marine grade units you might typically see on big yachts. And I've seen that one of the functions it includes is, quite precisely, monitoring the power at the dock. I'll be honest with you, I still haven't tried it. It looks fabulous. It's a domestic product, which is a good thing. In fact, they actually make it right here in Bilbao, not far from Santander, but it clearly doesn't fall into what I would call low cost either. I'm going to give it a try, and if I end up finding it interesting, I'll tell you about it at some point. But anyway, I didn't find anything Chinese that did that job, and yet it seems very useful to me if you usually leave your boat connected to the dock's power outlet. Hey, I'm one of those people who always keeps the boat plugged in when it's in the marina. Some of you will throw your hands up and start talking about the risks, galvanic currents, the boat burning up because of a short circuit, as if we didn't also have the electricity always on in our homes and the houses weren't burning down every other minute. The thing is, I use that boat very often, and I always have things like the fridge running and stocked with food and drinks. Aside from other things like the dehumidifier running continuously or all the monitoring systems that I like to always have ready. and that are precisely in charge of making sure the boat doesn't catch fire. Even in winter, I have an electric heater that I switch on remotely from home before I head down to the boat, which gives me two things. The boat is nice and warm when I arrive, and the engine is already warmed up too, so it starts up more easily. All of these comes at a cost. If the marina's breakers trip, or the ones on my own boat, or if someone disconnects your shore power cable by accident or with bad intentions, or for that matter if they do have bad intentions and someone steals your shore power cable, then what happens is everything starts drawing from the batteries, and the fridge, especially in summer, can drain a battery very quickly to the point of making it unusable. In my case, I receive a notification on my phone every time this happens, so I know whether the power went out, or they unplugged the cable, or they stole it from me. Even and above all, I know exactly at what moment this happens. In fact, that's how I looked up the recording from my security camera, at the exact moment when I saw a nice gentleman stealing the connection cable to the port from me. What happened to that guy? He didn't show up. He didn't show up? No. I'm convinced that he absolutely must have put it to very good use. Possibly the poor man simply needed a few extra meters of cable so that he could properly light up the Christmas tree at the children's hospital where he volunteers each and every year, for example. Almost certainly that was it. But the most important thing is that at that moment I can decide to remotely turn off the fridge and that way prevent my battery from dying, and when I come back I'll receive another alert and I can turn the fridge back on, or even go over to the boat in case there's any problem or whatever. So it works very wonderfully and can be quite useful. Let's go ahead and get on with the shopping. Well, I've already told you that I haven't been able to find on AliExpress a device equivalent to the one my company makes or the one from Dokensip. So we're going to build our own device with just 3 parts. What are we going to buy on AliExpress? 3 super simple things. First, a transformer from 220 to 5 volts, a 5 volt relay. We'll see that it can also be a really good idea to buy a few of the 12 volt ones as well to make other types of alarms, as we'll see at the very end, and most importantly our famous Wi-Fi flood detector. All in all, to build our device that detects when the power gets disconnected and sends us an alert to our phone each and every time that happens, we're going to spend a whopping 15 euros. It really doesn't get any cheaper. Let's go over the theory a bit of what we want to do. We want that every time there is power at an outlet and every time there stops being power, we get an alert on our phone notifying us. In the case of our boat, that will line up with when we unplug the connection cable from the dock or when the breakers trip, and similarly when the power comes back on or when we plug the cable back in again. Among the options we had, it was the simplest one, which would be a standalone device that performed that function like this one my company manufactures, the Sense Power, which would simply be to have it plugged into any outlet on the boat, and when there is power, when the power comes on, it lights up green, sends a notification to the phone. I would receive a notification here, and when the power goes out, it lights up red and sends another notification. As I told Carlos, it really isn't quite inexpensive enough for this channel. It's missing just a little bit of that truly low-cost element. The next option would probably be a monitoring system from those professional guys. Something like this one that looks really great, and apparently one of these devices, I believe it's this specific one, is a power detector. It's not cheap, it is indeed designed specifically for boats. In any case, we'll try it out since it surely works wonderfully, and maybe we'll come up with applications and ideas, or it's a solution for people who don't want to complicate their lives too much. And then there's our solution. Our solution is going to be based on the already well-known Wi-Fi flood detector. We've seen it on other occasions. We installed it as a Wi-Fi flood detector and put it in the bilge of our boat. In that case, it's simply that this is placed with its batteries and this goes near the place that can flood, and when the water reaches here, it creates conductivity between these two contacts, and that makes the alarm go off and the notification reaches us. And when it clears, there's no more water, this connection is released, and then we get another notification that there is no longer flooding. That's what we're going to use for our solution. Now, how can we realistically simulate these two contacts closing and then opening again when there is power or when there is no longer any power on our boat? We're basically going to use a relay. This would be our relay. Well, here it is in the bin from a bit farther away. But if you look at it closely, this is our relay. And with this relay, what we have is a 5 volt power supply. In our case, we selected 5 volts. I've already told you that you can use a 12 volt one, depending on what you're planning to connect. And here is the output. And on the outputs, we have a common terminal, which is where we will connect one of the terminals from our flood detector. And then we have one contact that is normally open and an NC contact that is normally closed. We want the normally closed, which is how it will be when there is no power, to be the alarm condition. So we are going to connect these two poles between the common and the normally closed. How do we make this relay change state each time there is power or each time the power stops? Well, we can do that pretty easily by using a 5-volt transformer. We'll plug this into any one of our outlets, and whenever there is power available, we will have 5 volts right here. Alright, we're going to connect those 5 volts to the relay's input. And then when there's power, the relay will turn on. When there's no longer power, the relay will turn off. But hey, that's going to cause these contacts to close when there's power, triggering the alarm. When there's no longer power, the contacts will open, the alarm will trigger again to let us know the change of state. So we're going to begin with our setup here, okay? We'll unplug it first, just for our safety. The very first thing we're going to do is to cut the cable on our transformer. We could cut it to just about whatever length we want. I'm going to leave it a little bit long. You can leave it at whatever length you might need at any given moment. The first thing we'll need to do is figure out which one is positive and which one is negative using a very simple multimeter. We plug it in, and I suspect that the black wire will be the negative and the white wire will be the positive. We set this to measure voltage, we turn it on, and here it shows us 5 volts positive when there's current in the pens, and then it drops to 0 volts when there stops being current. So then we're simply going to connect it directly into the input. And then first, just as we already know, the black wire is negative and the white wire is positive. We're going to connect it to the DC pin and also connect it to the DC pin on our relay. Now when we turn it on, it turns green, and when we turn it off, it turns off again. But nothing actually happens on the relay. Why? Because it has its own separate control line, which is the in line, and that's the line that will control whether we turn it on or not. A slightly longer small wire, if we apply 5 volts to the in pin, it changes its state accordingly. So what we're going to do is simply always keep these two bridged together. This is how the setup will end up. The black goes to DC, the white goes to DC plus, and then between the white and in, between DC plus and in, we put another little wire to make the bridge. We're going to decide which one of our two input contacts we're going to use. What we want is that when there's no power being applied, the circuit still remains closed. That's clearly the connection between COM and the normally closed contact. If we test it, okay, it's beeping, and if we power it on, it stops beeping. That means it opens up the circuit, and if the power goes out, it starts beeping again. The circuit closes back up again. Now we take it again just like we did last time, and we also cut the cable and strip the cable from our Wi-Fi flood detector. How many of those Wi-Fi flood detectors do you have? I don't know, I bought a batch of them. So now it's as simple as connecting these two, for example, the red one to COM and the white one to NC. Don't tell me it isn't easy, Carlos. I even see myself as capable of doing it even for you. Let's move in a bit closer. So what's the final connection? The final connection that we're expecting. And now all we have left is to set it up. We're going to clear things off and we take out the phone. It snaps like that, done. That snapping thing is really wonderful. Let's set it up just like we always do. First thing, just like always, go ahead and install the Tuya Smart app. You've got the links down in the description, so it's no problem at all. You probably already have it installed, like I do, and then we go straight to it. We open the Tuya Smart app. We're going to need 2 AA batteries for this. As you can see here, I've already got all the sensors we've installed previously listed. And what we're going to do now is add a brand new device right here. Just tap on Add Device. We're going to take it now and put the batteries into it. Protection sensor, Wi-Fi flood sensor. Here we select our boat's Wi-Fi network. It tells us to restart it by pressing and holding the button for 5 seconds until the indicator light begins flashing. It's already blinking, so we go ahead and tap Next. Then we look for the water leak sensor, and it has successfully detected it. Now it's installing it here. The progress bar is clearly visible and showing the installation progress as it completes. Well, the alarm goes off because we don't have power. We go ahead and click Next, and here we're able to edit it just like we did last time, but instead of it being a water leak sensor, we can name it Power on the Boat. As long as we have power, everything stays green. Here it says the status is correct. When we cut off the power, we receive the notification and it lets us know that we have a water leak alarm, but in this case, it's actually being used for the boat's power source. And that's it. Everything's ready. We already have our power alarm for the boat. Seeing this, you can imagine how easy it is to turn anything into an alarm. Anything you have on your boat or at home that beeps or that has an alarm indicator light can be used as the source to control the relay input. For example, if you want to monitor when the boat's ignition is turned on and when it's turned off, we can simply use a 12-volt relay instead of a 5-volt one. We connect everything in the same way, and then we control the relay input, for instance, by using the tachometer's power supply, which will have 12 volts every time the engine is running and will stop having it every time it shuts off, and that will activate and deactivate the relay. And we'll run the signal through our Wi-Fi alarm, or do the same for any small indicator light or alarm on our panel, because those little lights run on 12 volts. If we feed those 12 volts into the relay, that will cause the alarm to trigger or stop triggering depending on whether it turns on or off and while we're at it. Why not do it for the doorbell at home? Just have whatever powers the doorbell sound also power the input of a relay, and have that control our Wi-Fi flood sensor, and there you have it. When the doorbell is pressed, the relay closes, the alarm goes off, it communicates via jury, and the notification arrives. And I'm sure this is a starting point where you can think of tons of places to apply this, so I encourage you to share it with others in the comments. If you come up with any idea, I'd be happy. Where to apply it? Well, you tell us. The YouTube algorithm really loves comments about alarm automation ideas. That's what it likes the most, of course. But the algorithm also really likes it when you share our video as well too. Well, that's not what the algorithm likes, it's what we prefer. You can see just how easy it is to turn our flood detector into the foundation of basically any alarm for anything you might need on your boat. It's very simple and very inexpensive. I don't mean to devalue real marine systems or other kinds of detectors or even my own company's, but if you've already installed Wi-Fi on the boat and you want to do something very simple, then with the flood sensor or even with the door sensor, either one would work to do basically the exact same thing. You can also apply it to do it in this way. And that's really the philosophy of the channel, to give you ideas on how to turn things that have a common use into things that can be useful for your boats with a slightly different use. I really like that. It's just that it still isn't quite low cost enough. Well, going from 100 to 15 euros is a pretty significant difference. You can install a whole lot of those sensors. And going from 1000 to 15, the difference is honestly absolutely massive, and above all, it's really easy, and it's also about truly understanding it. In other words, in the end, it's not only about doing it, but actually understanding it. That's a philosophy, a way of working that's genuinely very easy. You have something that's going to transmit when the contact closes, and you have anything you want to monitor that can close that contact and then alert you right when that happens. I hope you enjoyed today's episode. If so, please remember to give us a like and subscribe to the channel. You've got the little bell to receive notifications. You have all the links to everything you've seen, and that appears in the video, both in the video's own description and on our website www.thelowcostsailor.com. We'll see you in 2 weeks in a new episode of The Low Cost Sailor. Just look, you've done it 27 times and it still never works. There's no way. There's no way. Hang on just a moment. Hang on.